So far we have talked about the Newtonian dynamics. We consider both momentum as P equal to the mass m times v. And also the energy E is equal to 1/2 of mv squared. So this is all within the framework of Newton. At the turn of the beginning of the 20th century, Einstein found that these equations need to be modified. In fact, what he found is that a mass that is at a velocity of 0, when accelerated to a velocity v, will have a mass that is increased. And in fact, this mass will be equal to m0 times square root of 1 minus v squared divided by c squared, where c is the speed of light, and that is greater than the rest mass of m0. So a mass becomes heavier at a high velocity, and in fact the mass would become infinite if v, the velocity of the particle relative to the reference frame, is equal to c, then the mass will become infinite. What it means is that we will still look at the momentum equation is still the same, which is P equal to m times v, but this mass is not the rest mass, but rather is the relativistic mass in motion. So we're going to refer to the invariant mass or the rest mass as m0, whereas the mass relative to the reference frame at a velocity of v as m, which is a function of the velocity. Having preserved the equation of momentum P equal to mv, we need to examine the equation E equal to 1/2 mv squared. And what Einstein found is that basically, if you look at a rest mass of m0, then the energy that is held by the mass itself would be equal to E equal to m0 c squared, where c is the speed of light. And in fact, even 1 gram of mass, if it's annihilated and completely turned into energy, would yield an energy E equal to mc squared. All right, so we need to, in fact, generalize the notion of the equivalence of energy and mass together with the notion of kinetic energy. So in this case here, what really we need to modify is that energy and in fact this is a much more general equation. The energy of a particle or a mass of rest mass of m0 will have a rest mass equivalent energy of m0 squared c to the 4th power. We're talking about the squaring, and what you have here is then the p squared of c squared. So this definition for energy, or you can basically E is equal to square root of this term here, consists of 2 parts. One, which is the rest mass of m0 of the object, together with the energies associated with that rest mass, plus the kinetic energy that's acquired by the mass, given by P, the momentum, defined by mv, and then the term need to be put together as P squared of c squared, and E squared will be given by this equation. Now, for example, if we have a mass of m0 that's at rest with respect to the reference frame then we have the equation of E equal to m0 c squared. So this is the famous Einstein equation that relate the rest mass to energy. And that answers Newton's earlier question that he posed at the end of his Principia Mathematica, that he asked the question whether mass and energy are convertible into each other. And the answer is yes, according to Einstein, that they are mutually convertible. Now, for example, if you look at this equation governs the conversion of mass into energy, and for photon, which has m0 equal to 0, photon has no rest mass because it never is at rest, then E would be equal to, this term is 0, would be equal to P times C, where P is the momentum of the photon. That is, a photon actually, even though it's no mass, still exert a momentum or a force when the photon hits a barrier and got absorbed. So E is equal to P times C for a photon. In the theory of relativity, we have both the conservation of momentum as well as the conservation of energy. In fact, the conservation of energy given by this equation would imply the conservation of momentum if you ignore the constant rest mass energy. Now also, you can define from this equation here a more easy to understand equation would be E equal to the rest mass times c squared divided by the square root of 1 minus v squared divided by c squared. What it's saying here is that if you have a rest mass that is moving at the velocity of v less than the speed of light, then this term over here corresponds to the mass at the velocity v. And so in the same sense that you have E equal to mc squared when the mass is not at rest but rather in motion at the velocity of v, the equation E equal to mc squared still holds. Instead of the rest mass, you have the relativistic mass. This is equivalent to this particular definition, equation of energy. So we're going to look at further how we can apply this special relativity and see how nuclear fusion as well as nuclear fission can be used to generate electricity.